Hello everyone. Today we are going to learn about 3D model. Lectures we have seen how to form a battery packs using a multiple type of cells, prismatic cell, cylindrical cell, pouch cells, and we have seen many types of components. For example, bus bar, cell holder, metal casing, charging discharging port. Which we can design for two-wheeler, three-wheeler, four-wheeler, even for forklift. Today we are going to learn how to form a 3D model for a two-wheeler and a four-wheeler battery packs. For example, why do we require a 3D modeling? So even when we go for raw ideas or even basic ideas, we have to define few things. For example, what type of cell we are going to use, what will be the sizing of the battery pack, and the mounting, as well as the placing of battery cells in the battery pack. Those things are important while going for the final designing. So that's why we required a 3D modeling. And basically, each and every company has their own 3D modeling softwares. Here we use SketchUp as a 3D modeling. So SketchUp is a user-friendly software, and you can easily form a 3D model in it. Where Today we'll see how to make components and how to form a battery pack using SketchUp. Later on, you can use the same file for detail manufacturing of a battery pack using required specifications. So here we go. Here you can see we have taken a cell holders. It is a radiant cell holders. We have seen it in our last session. We have a honeycomb cell holder as well as epoxy sheet. But these are the standard types of cell holder, mostly used in two-wheeler battery packs, for LFP battery packs, for NMC battery packs. And this is a insulator material used in between the two battery pack. I will show you how to. So here you can see we have taken a radiator seal holders and insulator PVC for insulation. Now we have taken these LFP cells, which here you can see. These are the LFP cells with the configuration of 32-650. What is 32? 32 is the diameter of a cell, individual cell, and 650 is the height of the cell. So with respect to that, we have to select the cell. For example, in 18650 LFC cell, we use a diameter of 18 for this cylinder. But right now we are using the 32-650. So the diameter would be 32 or a little more than that to get a complete and better fitment. So we have taken these cells in series and parallel, as well as here you can see the nickel strips. So mostly in two-wheeler and lightweight applications, manufacturer prefer nickel strips, which has a good conductivity. And in heavy duty like forklift and car and three-wheeler, mostly we used copper and nickel as well as. It depend on the costing and the conductivity. So today we'll go with the nickel strip. So this is the complete cell which we can put it in a cell holder, and later on we can spot this nickel strip on the cell. So here you can see the casing. So casing is nothing but a made up of a MS metal in 1.2 thickness. It's a simple casing for battery packs. The size is depend on the available space in a battery. We have already seen it in our last. Yeah. So here you can see complete casing. There are a few ports in the casing given. One is for charging port and one is for a discharging port. So in charging port, basically we plug in the charger for charging, and in discharging port, basically the output goes to the vehicle end where the discharging of battery happens. So mostly we use Anderson connector, which is a standard, and it can sustain a heavy current for discharging. So these plus and minus, you can see the color coding is in black and red. So black is a negative terminal and red is a positive terminal, which goes to the vehicle end for the discharging purpose. So now we'll place a battery pack in the casing, so we can see how much space is available and the size of the battery packs. So these are made of in 32-650 cells. So here you can see we have placed it in a vertical format. So either you can place it in a horizontal, either you can place it in a vertical form according to your availability and space. So mostly here the space was available for height, so we have gone for the vertical placement. So this is a battery pack for 60 volt 30 Ah. You can see here we can adjust the battery cell. So we have given some clearance in the bottom side and right side a little bit for insulation. So we can add some insulation over here. So avoid a short circuit and any kind of metal contact, because the casing is made up of metal. So we have to taken care of all those things. So now we have replicated the number of cells. Here you can see. Now we have to place insulation in the battery pack. Here you can see we have provided the insulation. Here it is the insulation sheet, and here it is also in the all side we have to place that insulation sheet. So none of a battery cell or any metal part get in contact with the casing, which will directly lead to the short circuit and the thermal runaway, and sometimes explosion can be happened. So we have to use this type of thermal padding or insulator in between the cell. And here you can see the BMS is placed on the top of the battery pack. So we have seen the BMS is selected according to the battery pack, how much battery pack we are using. For example, we have gone for a 60 volt. So in a LFP format. So basically we have used a 19 series BMS. So 19 series BMS has that capacity to sustain till the 30 Ah and more than that while discharging. And these cells are 3C rating. Later on, we'll explain you how to measure the 3C rating and how to do those things. So this was the part for bike battery pack.